Hello and welcome to a lesson on creating a histogram in Python. But before we jump into looking at how to write a program that can generate a histogram, we are going to go over the previous program that was in the previous lesson. And so it was a bar graph. Okay, so that was what the program was creating. So this code snippet is used to create and display a bar chart using the matplot library in Python. And we're going to go over the code step by step to see what it does. So first we want to import the matplot library by typing in this command here, import matplotlib.pyplot as plt. So this line imports the pyplot module from the matplot library and assigns it the alias plt. The pyplot module provides functions for creating plots and charts. And so then what we do is we define the data. So we have two lists here. Okay, so one of the lists is subjects. And so we have math, science, English, history, and art. So these are strings. As we can see there, they are in single quotes here. And then matching these subjects, we have 5 marks. Okay, so 75 for math, 85 for science, 90 for English, 80 for history, and 70 for art. So these two lines define the data to be plotted. Subjects is a list of strings representing the different subjects, and marks is a list of integers representing the marks for each corresponding subject. Now this line here creates a bar graph. So plt.bar, and then in parentheses, subjects, comma, marks. So there are 2 arguments here that this bar function takes. So this line, creates a bar graph. The plt.bar function takes 2 arguments, the categories for the x-axis, which is the subjects, and the values for the y-axis, the marks. And then it plots a bar for each subject with a height corresponding to the mark. Now, this line here, plt.y, so plt.x label is just to add a label to the x-axis, and the label is subjects. And then plt.y label adds a marks label to the y-axis. So we're just labeling the axes here. Now we also have a title added as well, plt.title, and it's marks by subject. So this line sets the title of the chart to marks by subject. And then finally, we have this plt.show function, and this displays the chart. Okay, so the plt.show function renders the chart and opens a window or displays inline in a Jupyter notebook, showing the bar chart with the specified labels and title. So in summary, this code snippet generates a bar graph that visualizes the marks for different subjects with appropriate labels for the x-axis, y-axis, and the chart title. So let's have a look at the output code here. So I'm going to go to bar graph. I'm going to run it again. And what we see is that Python generates a nice looking bar graph. We can see the title, scores by subject. So I'm going to actually change this because this is actually marks. So marks, let's change that. And this should be marks as well. And then this will change to marks as well. It's supposed to be marks by subject. Okay, let's run it again and see how it looks like. Yeah, so we have marks by subject. We're labeling the y-axis with the title marks. And then we're giving so the x-axis, all it has is Um, it's just too close to the English, but yeah, it does have, it is labeled. The x-axis is labeled as subjects. And then we do have a title, and we can see the bars, and we have a scale along the y-axis. So the highest mark here was 90 for English, and it does appear like it's about, yeah, looks like it's about 90. Okay, so now let's also look at how to generate a histogram in Python. So a histogram is a type of graph used to represent data. It looks similar to a bar chart, but it's used for a different purpose. Here's a simple way to understand what a histogram is and how it can help you understand data better. A histogram is a visual representation of how often different ranges of values occur in a data set. It shows the frequency or count of data points within the specific ranges called bins. So here we have the key parts of a histogram. There are bins or intervals. So these are the ranges of values into which the data is grouped. Each bin represents a range of values. There are bars, just like in a bar graph. So each bar represents the frequency, so the number of data points that fall within each bin or each interval. The height of the bar shows how many data points are in that bin or that interval. So here we have an example of some data. We have test scores. So imagine we have 30 students and we have 30 test scores. So a histogram helps you see how these scores are distributed across different ranges. And so this is how you could create one. So you could decide on the ranges for the bins. For example, you might use 60 to 69, 70 to 79, 80 to 89, and 90 to 99. We can see that the lowest mark here appears to be something in the 60s. There's a 68 here, there's a 67. So it looks like 67 is the lowest mark. And then the highest mark appears to be 90 something, 93, I think is the highest. Or actually, no, 95. It looks like here is the highest mark. We can see that all the intervals are the same length. They're all 10 values if we're considering the values to be integers. So the next thing we want to do is we want to count. So we want to determine the frequencies. We want to figure out how many scores fall into each range. So we will have to go back and actually count. So there are 3 scores that are between 60 and 69. So including 60 and 69, there's one over here, 67, and then there's 69, and lastly there's 68. So there's 3 scores. Then between 70 and 79, there's 7 scores. Between 80 and 89, there's 12. Between 90 and 99, there's 8 scores. And so in total, there are 30 test scores. And so then the last thing we want to do is now we can actually draw the histogram. So each bin will have a bar whose height corresponds or represents the number of scores in that range. Now, why would we even want to use a histogram? So it helps us visualize data. It helps you to see how data is spread out across different ranges. It can be used to identify patterns. You can easily see which ranges have the most or least data points. You can analyze the distribution of the data, understand whether the data is skewed towards certain values. So towards, let's say, the 90s or towards the 60s, or if it's balanced based on where the bar is of the highest height, or where most of the bars are concentrated. Are they towards the top of the data range or towards the bottom, or is it in the middle? So here we have an example of the actual program. So this is how we would write a program. So we would define, well, before we define anything, we actually need to import the matplot library. Yeah, I'm gonna go back here and let's have a look. So yeah, so we import the matplot library first. We've seen this before, this this command here, this line of code in previous lessons. And next we want to, so we define an array or a list. Okay, so we just have a list of integer values here, 30 values that we're storing in this this variable here, this list actually. So test underscore scores. Now to create the histogram, we need to use this function plt.hist, and then it accepts some arguments here. So it acts on the test underscores list. So it will take the values from this list, and it's going to generate bins. So when we enter it this way, so bins equals, and then 60, 70, 80, 90, 100, it will generate from 60 to 69, 70 to 79, 80 to 89, 90 to 99. Okay, that's what this means. Edge color, it says it's black. Color, sky blue. Okay, so this is just the color of the bar, of each bar, and then this is the like the outline of it. And then we add labels. So add labels and a title. We label the x-axis as score ranges. We label the y-axis as number of students, and then finally we also label the top of the graph. We add a title, distribution of test scores. And so this is what is generated. Notice there's no separation between the bars. That's how histograms are. And we have our title, we have our axes labeled, and we can also see our intervals or bins, our test ranges on the bottom here. So it appears that most of the students in this class on this particular test scored between 80 and 90. Okay, so between 80 and 89. So that was the abundance, like most of the students were in this test score range. And then there were also some that were in the 90s as well. Not many, very few were that a score between 60 and 70. Yeah. So for the most part, the data is being skewed towards this bar over here. So there's more data in the upper ranges than in the lower ranges, which is, I mean, a good thing for test scores. Okay, and so that brings us to the end of this lesson. Thank you for watching.